Configuration in Log4j. Now we are focusing on configuration. Every logger context has an active configuration. The configuration contains all the appenders, context-wide filters, logger configs, and contains the reference to the str substitutor. During reconfiguration, two configuration objects will exist. Once all loggers have been redirected to the new configuration, the old configuration will be stopped and discarded. Here you can see the DTD for the configuration document supported by the DOM configurator of Log4j version 1.1.3. The XML-based org.apache.log4j.xml.dom configurator configures the class offers more configuration class offers more flexibility and benefits and drawbacks of the XML-based configuration. This is here log4j colon configuration interacts with XML ns colon log4j string. Disable */ enumeration and disable override */ enumeration and debug */ enumeration and config debug */ enumeration and renderer and root renderer interacts with renderer class string and rendering class string. Here the append interacts with name, ID and string and error handler, param, layout and append -ref. Here the error handler interacts with class string and param interacts with name, string and value string. Here the param interacts with name, string and value string, and here the layout interacts with class string and param interacts with name, string and value string, and here filter interacts with class string and param interacts with name, string and value string. Here the append -ref interacts with ref, ID ref. Here the category interacts with class string, name string, additivity */ enumeration, and param and append /ref. Here the param interacts with name string and value string, and here the parrot interacts with class string and value string and param interacts with name string and value string, and append interacts with append -ref interacts with ref, ID ref. Here root interacts with param and append -ref, and here the param interacts with name string, value string. Here the parrot interacts with class string, value string and param interacts with name string and value string, and here append -ref interacts with ID ref, ID ref. Here you can see the DTD for the configuration document supported by the Log4j version 1.2.3 DOM configurator. Here the Log4j colon configuration interacts with XML ns colon log4j string, threshold */ enumeration and debug */ enumeration, renderer, category and category factory, renderer interacts with renderer class string and rendering class string. Here the appender interacts with name id class string, error handler, and then appender dash ref. Error handler interacts with class string, param, and param interacts with name string and value, and here root dash ref, and here the logger dash ref interacts with ref id ref. Here the error handler interacts with appender dash ref. It interacts with ref id ref. Here the param interacts with name string and value string. Here the layout interacts with class string, param, and here the filter interacts with class string and param. Here the appender ref interacts with ref id ref. Here the category interacts with class string, name string, additivity */ enumeration, and param and appender dash ref. Here param interacts with name string, value string. Parrot interacts with class string and value string, and param interacts with name string and value string. Here level interacts with class string and value string, and param interacts with name string and value string. Here the logger interacts with name id and additivity */ enumeration, and level and append dash ref, and level interacts with class string and value string, and param interacts with name string and value string. Here the root interacts with the param and append dash ref. Param interacts with name string and value string. Here the priority interacts with class string, value string, and here param interacts with name string and value string. Here the level interacts with class string and value string, and param interacts with name string and value string. Here append dash ref interacts with ref. Here the category factory interacts with class string and param interacts with name string and value string. Here you can see Log4j configuration process. Right into the configuration class. Once we have here the Log4j API already provides two classes for configuration: basic configurator, which is capable of providing the basic configuration for the Log4j framework; the DOM configurator, which is capable of loading configuration information from an XML file. We can write our own configuration class to configure the Log4j framework from the database. This figure shows the sequence of Log4j initialization. Each time we try to obtain a logger by calling logger.getLogger, logger name, the log manager class get initialized. Log manager collects then inspect the system properties snippet to the Log4j from the command line. Remember that this is happening at the class loading time of the log manager in a static block, and this takes place once and only once. Log manager detects the configuration file specified via command line system properties. It then calls the option converter helper class to pass the information contained in the files. The option converter class instantiates an appropriate configurator class and calls the doConfigure method to complete the configuration process. Log4j relies on the fact that configuration information should be specified in the configuration file accessible through a URL. No configuration resource file is specified. The Log4j tries to look for the default configuration file, the log4j.properties, in the class path of your application. Here the class logger, the core implementation of the logger interface. Beside providing an implementation of all the logger method, this class also provides some convenience method for Log4j 1.x compatibility, as well as across access to filters and appenders associated with this logger. Note that access to this underlying object is provided primarily for use in unit test or bridging legacy Log4j 1.x code. Class log manager and log manager, the anchor point for the Log4j logging system. The most common usage of this class is to obtain the named logger. The method getLogger is provided as the most convenient way to obtain the named logger based on the calling class name. This class also provides method for obtaining named loggers that use string.format, string object style messages instead of the default type of parameterless messages. These are obtained through the getFormatterLogger class family of methods. Other service provider methods are given through getContext, getFactory methods family of methods. These methods are not normally useful for typical usage of Log4j. Class option converter, the convenience class to convert property values to specific types. Class configurator initializes and configure the logging system. This class provides several ways to construct a logger context using the location of the configuration file, a context name, and various optional parameters. Here the application is connected to the logger, then logger is connected to the log manager. Here the log manager is connected to the option converter, then the option converter is connected to the configurator. As an example, we can consider interface configuration. Interface that must be implemented to create a configuration. This is in package org.apache.logging.log4j.core.config. As an example 2, we can consider class abstract configuration, the base configuration. Many configuration implementations will extend this class. This is in Apache. This is in package org.apache.logging.log4j.core.config. Here you can see initialize Log4j using configuration builder with the custom configuration factory. The interface configuration factory textend configuration interface for building logging configurations. This is in the interface configuration builder textend configuration. This is a interface for building logging configuration. This is in package org.apache. logging.log4j.core.config.builder.api. Here the class configuration factory, the factory class for past configuration object from a configuration file. Configuration factory allows configuration implementation to be dynamically chosen in one of three ways. A system property named log4j dot configuration factory can be set with the name of configuration factory to be used, or set configuration factory can be called the instance of the configuration factory to be used. This must be called before any other calls to log4j. A configuration factory implementation can be added to the class path and configured as a plugin in the configuration factory category. The old annotation should be used to configure the factory to be the first one inspected. This class is in package org.apache.logging.log4j.core.config. One way to programming configure log4j2 is to create custom configuration factory that uses configuration builder here to create configuration. This example overrides get configuration methods to return configurations created by the configuration builder. This will cause the configuration to automatically hooked into log4j when logger context is created. In this example, because it specifies a supported file type asterisk, it will override any configuration files provided. Here in set, this is a configuration builder. Set configuration sets the name of the configuration. Here set status level sets the level of the status logger. Here in add adds a filter component. Here in this adds an appender component. Here add the logger component. Here too. And here in the build, builds the configuration and optionally initialize it. Here as example 4, we can consider reconfigure log4j using configuration builder with the configurator. Here the class configurator initializes and configure the logging system. This class provides several ways to construct a logger context using the location of configuration file, a context name, and various optional parameters. This is in package org.apache.logging.log4j.core.config. Here you can see the configuration builder interface for building logging configurations. Here you can see configuration builder factory this provides methods to create configuration builders. Here the new configuration builder here returns a new default configuration builder to construct log4j configurations. Here set status level sets the level of the status logger. Here set configuration name sets the name of the configuration. Here in the adds a filter component, and here adds an appender component here. Here add the logger component. This is initialize log4j by combining configuration file with programmatic configuration. Here the interface configuration, interface that must be implemented to create a configuration here is in package org.apache.login.log4j.core.config. Here in get configuration returns the current configuration. As an example 6, we can consider arbiters. In some situations it is desirable to have a single logging configuration that can be used in any deployment environment. For example, it may be necessary to have a different default logging level in production than in development. Another case might be where one type of appender is used when running natively, but another is used when deployed to a Docker container. One way to handle this, that is to use a tool such as Spring Cloud Config Server that can be environment aware and serve the different file for each environment. Another option is to include arbiters in the configuration. An arbiter is a log4j plugin that has the job of determining whether other configuration elements should be included in a generated configuration. While all other core plugins are designed to execute as part of log4j runtime logic, arbiters execute after the node tree has been constructed but before the tree is converted to a configuration. An arbiter is a node itself, which is always removed from the node tree before the tree is processed. All an arbiter really does is provide a method that returns a Boolean result that determines whether the child nodes of the arbiter should remain in the configuration or be pruned. Arbiters may occur anywhere an element is allowed in the configuration. So an arbiter can encapsulate something as simple as a single property declaration or the whole set of appenders or loggers. Arbiters may also be nested, although arbiters that are descendant of another arbiter will only be evaluated if the ascender return true. The child elements of an arbiter must be valid elements for whatever element is the parent of the arbiter. This example shows two arbiters configured that will include either a console appender or a list appender, depending on whether the value of environment system property is dev or production prod. As an example 7, we can consider automatic configuration. Log4j has the ability to automatically configure itself during initialization. When Log4j start, it will locate all the configuration factory plugins and arrange them in weighted order from highest to lowest. As delivered, Log4j contains 4 configuration factory implementation, one for JSON, one for YAML, one for properties, and one for XML. Here Log4j will inspect the log4j2.configuration step 1. Log4j will inspect the log4j2.configuration file system property, and if set, will attempt to load the configuration using the configuration factory that matches the file extension. Note that this is not restricted to a location on the local file system and may contain a URL. This step 2. If no system property is set, the properties configuration factory will look for log4j2-test.properties in the class path. Step 3. If no such file is found in the YAML configuration factory, will look for log4j2-test.yaml or log4j2-test.yml in the class path. If no such file is found, the JSON configuration factory will look for log4j2-test.json or log4j2-test.jsn in the class path. Step 5. If no such file is found, the XML configuration factory will look for log4j2-test.xml in the class path. Step 6. If a test file cannot be located, the properties configuration factory will look for log4j2 properties on the class path. Step 6. If a properties file cannot be located, the YAML configuration factory will look for log4j2.yaml or log4j2.yml on the class path. Step 8. If a YAML file cannot be located in the JSON, the JSON configuration factory will look for log4j2.json or log4j2.jsn in the class path. Step 9. If a JSON file cannot be located in the XML configuration factory, if a JSON file cannot be located, the XML configuration factory will try to locate log4j2.xml on the class path. And step 10. If no configuration file could be located, the default configuration will be used. This will cause logging output to the console. As an example 8, we are considering configuration with XML. Log4j can be configured using two XML flavors, concise and strict. This is concise. The concise format makes configuration very easy, as element names match the component, and they represent. However, it can be cannot be validated with XML schema. For example, the console appender is configured by declaring an XML element named console under its parent appender's element. However, element and attribute names are not case sensitive. In addition, attributes can either be specific as an XML attribute or as an element that has no attributes and has a text values. And the this file represent the structure of an XML configuration. No, but note that the elements in italics below here represent the concise element names that would appear in their place. This is a strict XML. In addition to console XML format previously, Log4j allows configuration to be specified in a more normal XML manner that can be validated using XML schema. This is accomplished by replacing the friendly element names above here with their object type as shown here. For example, instead of the console appender being configured using an element named console, it is instead configured as append element with type attribute containing console. Here you can see the configuration with JSON. In addition to XML, Log4j can be configured using JSON. The JSON format is very similar to concise XML format. Each key represents the name of the plugin. And the key value pairs associated with it are its attributes. Where key contains more than a simple value, it itself will be subordinate pattern. So subordinate plugin. Sorry. In this example, threshold filter, console, and pattern layout are all plugins, while the console plugin will be assigned a value of std out for its name attribute, and threshold filter will be assigned a level of debug. Note that in the routing appender, the root element has been declared as an array. This is valid because each array element will be a route component. Log4j, this is configuration with YAML. Log4j also supports using YAML for configuration files. The structure follows the same pattern as both XML and YAML configuration formats. You can see here. And additional runtime dependencies are required for using YAML configuration files. Here you can see configuration with properties. As of version 2.4, Log4j now supports configuration via properties files. Note that the property syntax is not the same as the syntax used in Log4j1. Like the XML and JSON configuration, properties configuration define the configuration in terms of plugins and attributes to the plugins. Prior to version 2.6, the properties configuration requires that you list the identifiers of the appenders, filters and loggers in a comma separated list in properties with with those names. Each of those components will then be expected to be defined in a set of properties that begin with component.identifier. Identifier does not have to match the name of the component being defined, but must uniquely identify all attributes and subcomponents that are part of the component. If the list of identifiers is not present, the identifier must not contain each individual component must have a type attribute specified that identifier is a component's plugin type. As of version 2.6, this list of identifiers is no longer required, as names are inferred upon the first usage. However, if you wish to use more complex identifier, you must still use the list. If the list is present, it will be used. Unlike base component, when creating subcomponents, you cannot specify an element containing a list of identifiers. Instead, you must define a wrapper element with its type. This example demonstrates how the shorthand is expanded when reading properties configuration. You can see the as an example 13, you can see the scripts. Log4j provides support for JSR 223 scripting languages to be used in some of its components. Log4j provides support for JSR 223 scripting languages to be used in some kind of its components. Any language that provides support for JSR 223 scripting engine may be used. A list of languages and bindings for them can be found in at the scripting engine website. However, some of the languages listed there, such as JavaScript, Groovy, and Bean Shell, directly support JSR 223 scripting framework and only require that the jars for that language be installed. As of Log4j 2.17.2, the languages to be supported must be specific as a comma separated list in the log4j2.script.enable languages system property. The components that support using script to script do so by allowing script script file or script reference, script ref. element to be configured on them. The script elements contains name for the script, the language of the script, and script text. The script file element contains the name of the script, its location, its language, its charsets, and whether the file should be washed for changes. The script ref element contains the name of the script that is defined in the script configuration element. The name of the script is used to store script along with the script. It's a script engine, so it can quickly be located each time the script need to be run. While the name is not configured, providing it will help in debugging problems when the script is running. The language must be provided on the script element must specify one of the language names appeared in the configuration status log as described, and in the languages, if the language is not specified on the script element, if the language is not specified on the script file element, the language will be determined by the file extension of the script path. If the monitoring is requested, it will only be enabled if the non-zero monitor interval is specified in the configuration element. This interval will be used to check for changes in the file. If the status attributes on the configuration element is set to debug, the list of script engines currently installed and their attributes will be listed. You can see here. Although some engines may say they are not thread safe, Log4j takes the steps to ensure that the script will run in a thread safe manner if the engine advertises that it is not thread safe. This is example for X-include. XML configuration file can include other files with X-include. Here's an example of log4j 2.xml file here that includes two other files. This is as an example 15, we can consider composite configuration. Log4j allows multiple configuration files to be used by specifying them as a list of comma separated paths on log4j.configuration file, or when using URLs by adding secondary configuration locations as query parameters named override. The merge logic can be controlled by specifying a class that implements the merge strategy interface on the log4j.merge strategy property. The default merge strategy will merge the files using following rules. Global configuration attributes, step 1, the global configuration attributes are aggregated with those in later configuration, replacing those in previous configuration with exceptions. High status will be used. The lowest monitor interval greater than 0 will be used. Packages are joined with comma. Step 2, properties from all configurations are aggregated. Duplicate properties replace those in previous configuration. Step 3, filters are aggregated under a composite filter if more than one filter is defined. Since filters are not named, duplicates may be present. Step 4, scripts and script file references are aggregated. Duplicate definitions replace those in previous configurations. Step 5, appenders are aggregated. Appenders with the same name are replaced by those in later configurations, including all the appenders subcomponents. Step 6, loggers are all aggregated. Logger attributes are individually merged with duplicates being replaced by those in later configurations. Appender references on a logger are aggregated with duplicates being replaced by those in later configurations. Filters on a logger are aggregated under a composite filter if more than one filter is defined. Since filters are not named, duplicates may be present. Filters under appender references included or discarded depending on whether their parent appender reference is kept or discarded. As an exception, now we are considering configuration. The configuration of log4j2 can be accomplished in one of four ways. One, through the configuration file written in XML, JSON, YAML or properties format. Two, programmatically by creating a configuration factory and configuration implementation. Three, programmatically by calling the API exposed in the configuration interface to add component to its default configuration. Four, programmatically by calling methods to internal logger class. Inserting log request into application code requires a fair amount of planning and effort. Observation shows that approximately 4% of the code is dedicated to logging. Sequentially, even moderately sized application will have thousands of logging statements embedded within their code. Given their number, it becomes imperative to manage this log statement without the need to modify them manually. Configuration of log4j2 can be accomplished in one of the four ways here. All available formats are functionally equivalent. For example, the configuration file in XML can be written using properties format and the opposite without any loss of functionality. However, the hierarchical nature of log4j configuration can be captured better in formats which naturally support the nesting of XML, JSON, and YML files are usually easier to use. Note that unlike log4j 1.x and the public log4j2 API does not expose methods to add, modify, or remove appenders and filters or manipulate the configuration in any way. Now we are considering architecture. The Once the node tree is created, control is delegated to abstract configuration, which converts the nodes into their respective Java objects using Log4j's plugging system and provides all the common functionality. The class abstract configuration in package org.apache.login.log4j.co.config in module org.apache.login.log4j.co. The base configuration, many configuration implementation will extend this class. As in part because support for XML was added first Log4j's configuration is reflected as a tree structure. In fact, every configuration dialect, including configuration builder, generates a node for every configuration element. A node is fairly simple structure that contains a set of attributes, a set of child nodes, and a plugin type. It is important to note every node must have a corresponding plugin, as the plugin is component that actually perform the work represented by the node. Every document type supported by Log4j has a configuration factory. The factory itself is a Log4j plugin that declares what file extension it supports and what its priorities. Properties have the highest precedent with a value of 8, followed by YAML, JSON, and XML. When auto configuration is performed, Log4j will call each of these factories in order to determine which, if any, support the specified configuration file format. If one is found, that the factory will create a corresponding configuration object that passes the reference to the configuration data to it. Every configuration implementation, such as XML configuration, YAML configuration, JSON configuration, etc., has the primary task of converting the configuration text into the tree node, typically passing the text with whatever tool is available for that document type. It should be noted that while the most of the supported documents types are inherently tree structured, the Java property syntax is not. Because of the need to convert the syntax into a node tree, the Java property syntax used by the Log4j required all properties follow a naming pattern that made the tree structure clear. As a consequence, Java properties format tend to be the more verbose than using different document type. Once the node tree is created, control is delegated to abstract configuration, which converts the nodes into their respective Java objects using Log4j's plugging system and provide all the common functionality. Now we are considering arbiters. This example shows two arbiters configured that will include either a console appender or a list appender, depending on whether the value of the env system property is div or prod. The interface arbiter in package org.apache.login.log4j.co.config.arbiters in module org.apache.login.log4j.co. Interface used to check check for portions of the configuration that may be optionally included. Some situations it is desirable to have a single logging configuration that can be used in any deployment environment. For example, it may be necessary to have different default logging level in production than in development. Another case might be where one type of append is used when running natively, but another is used when deployed to a Docker container. One way to handle this is to use the tool such as Spring Cloud Config Server. That can be environment aware and serve a different file for each environment. Another option to include arbiters in the configuration. An arbiter is a Log4j plugin that has the job of determining whether other configured elements should be included in the generated configuration. While the other core plugins are designed to execute as part of Log4j's runtime logic arbiters, runtime logic arbiters execute after the node has that node tree that has been constructed, but before tree is converted into configuration. The arbiter is a node itself, which is always removed from the node tree before the tree is processed. All an arbiter really does is to provide a method that return a Boolean result that determine whether the child node of the arbiter should remain in the configuration or be pruned. Arbiters may occur anywhere anywhere an element is allowed in the configuration. So an arbiter could encapsulate something as simple as a large single property declaration or whole set of appenders and loggers. Arbiters may also be nested through arbiters that are the descendant of another arbiter. Will only be evaluated if the necessary return true. The child element of an arbiter must be a valid element for whatever element is present, is the parent of the arbiter. This example shows two arbiters configured that will include either a console appender or list appender, depending on whether the value of env system property is div or prod. Arbiters normally act in isolation from other arbiters. That is, the outcome of one arbiter will not impact the any other arbiters. This can be cumbersome when you simply want to use one of the set of choices. The special plugin named select can be used in this case. Each element under select is required to be an arbiter. The first arbiter that returns a true value will be the one used, while others are ignored. If no arbiter returns true, the default arbiter may be configured with the default configuration element. The default arbiter is an arbiter that always returns true, so using it outside of the select would return in its configured element always being included, just as if it hadn't been present. This example shows an arbiter that uses script reading in a separate file to determine whether to include the console appender. If the result is false, then the list appender will be included. Natively, Log4j contains a system property arbiter that evaluates whether to include the element based on whether a simple property is null or has a specific value. A class arbiter that makes a decision based on whether the specified class is present, and the script arbiter makes this decision based on the result of the script configured with it. For string boot, uses the arbiter name called spring profile and closing code has been provided. The specified profiles are evaluated by Spring's code and environment.accepts profile method, closing code method. So any expressions that support may be used as the name attribute. In this example, we'll use console appender when a Spring profile is div or staging, and the list append when the active profile is prod. Now we are considering automatic configuration. An example application named MyApp that uses Log4j can be used to illustrate how this is done. Log4j has ability to automatically configure itself during initialization. When the Log4j start, it will locate all the configuration factory plugins and arrange them in a weighted order from highest to lowest. As deliver Log4j contains 4 configuration factory implementation: one for JSON, one for YAML, and one for properties, and one for XML. Log4j will inspect log4j.configurable file system property. If it's set, it will attempt to load the configuration using the configuration factory that matches the file extension. Note that this is not restricted to a location on the local file system and may contain a URL. 2. If no system property is set, the properties configuration factory will look for log4j2-test.properties in the class path. 3. If no such file is found in the YAML configuration factory, it will look for log4j2-test.yml or log4j2-test.yml in the class path. 4. If no such file is found in the JSON configuration factory, we'll look for log4j2-test.json or log4j2-test.json in the class path. If no such file is found in the XML configuration factory, it will will look for log4j2-test.xml in the class path. If 6, if a test file cannot be located in the properties configuration factory, we'll look for log4j2.properties on the class path. 7, if a properties file cannot be located in the YAML configuration factory, we'll look for log4j2.yml or log4j2.yml on the class path. If YAML cannot be located in the JSON factory, we'll look for log4j2.json or log4j2.json on the class path. If a JSON file cannot be located in the XML configuration factory, we'll try to locate log4j2.xml on the class path. If no configuration file can be located, default configuration will be used. This will cause logging output to go to the console. An example application named MyApp that uses Log4j can be used to illustrate how this is done. MyApp begins by importing Log4j related classes. Then it defines static logger variable within the app, within the with the name my app, which happens to be the fully qualified name of the class. My app uses the bar class defined in the package com.foo. Log4j will provide the default configuration if it cannot locate the configuration file. The default configuration provided in the default configuration class will set up a console append attached to the root logger. A pattern layout set to the pattern here attached to the console append. Note that the default log4j assigns the root logger to level .error. The output of my app would be similar to so here as was described previously, the log4j will first attempt to configure itself from the configuration files. The configuration equivalent to the default would like here. Once the file above is placed into the class path as log4j 2.xml, you will get the result identical to those listed above. Changing the root level to the trace will result in the result similar to here. Note that the status logging is disabled when the default configuration is used. Define static logger variable so that the references the logger instance named my app. Set up a simple configuration that log on the console. Sorry, it's here. If there if the error level is trace, then we can redo it again with the trace. Now we are considering configuration from a URI. If it does, Log4j will validate that the file URL is valid and continue processing as processing. If it contains a protocol other than file, then Log4j will inspect the value of the log4j2.configuration.allowed protocols system property. When log4j2.configuration file references a URL, the log4j will first determine if the URL references a file using file protocol. If it does, log4j will validate that the file URL is valid and continue processing as continue processing. If it contains a protocol other than the file, then log4j will inspect the value of the log4j2.configuration.allowed protocols system property. If the provided list contained protocol is specified, then log4j will use the URI to locate the specified configuration file. If not, an exception will be thrown and an error message will be logged. If no value is provided for the system property, it will default to HTTPS. Use of any protocol other than file can be prevented by setting the system property value to _none. This value would be an invalid protocol, so cannot conflict with any custom protocols that may be present. Log4j support access to remote URLs that require authentication. Log4j supports basic authentication out of the box. If the log4j2 configuration.username and log4j2 configuration.password are specified, those values will be used to perform the authentication. If the password is encrypted, a custom password decryptor may be supplied by specifying the fully qualified class name in the log4j2.configuration.password decryptor system property. A custom authentication provider may be used by setting the log4j2 configuration authentication provider system property to the fully qualified class name of the provider. Now we are considering additivity. Simply a change in the log level would not accomplish the task. Instead, the solution is to add a new logger definition to the configuration. Class here the perhaps it is decided to eliminate all the trace outputs from everything except com.foo.bar. Simply change in the log level would not be accomplished this task. Instead, solution is to add the new logger definition to the configuration. With this configuration, all log events from the com.foo.bar will be recorded, while only error events will be recorded from all other components. Now we are considering automatic reconfiguration. The minimum interval is 5 seconds. The interface the method configuration build t set monitor interval string interval second. In interface configuration build t extend configuration in package org.apache.login.log4j.co.config.builder.api in module log.apache.login.log4j.co. That method, this method sets the interval at which the configuration file should be checked for changes. When configured from a file, Log4j has the ability to automatically detect changes to the configuration file and reconfigure itself. If the monitor interval attribute specified on the configuration element and is set to non-zero value, then the file will be checked the next time the log event is evaluated and or logged and the monitor interval has elapsed since the last check. The example here shows how to configure the attribute that so that the configuration file will be checked for any changes only after at least 30 seconds have elapsed. The minimum interval is 5 seconds. Now we are considering concise syntax in configuration syntax. The file here represents the structure of an configuration file, so structure of an XML file, but not that the element in italics below represent the concise element names that would be appear in their place. The concise format makes configuration very easy as the element names match the components they represent however it can be validated with an XML schema. For example, the console append is configured by declaring XML element named console under its parent appenders element. However, the element and attributes names are not case sensitive. In addition, the attributes can either be specified as an XML attribute, so an XML elements that has no attributes and add sets has a text value. So here and here are equivalent. These two. The file below represent the structure of an XML configuration, but note that the see the many example on here. The these appends, you can see here appenders and logger declarations. Here the package org.apache.login.log4j.co.config.xml in module org.apache.login.log4j.co, the classes and interfaces supporting configuration of log4j2 with XML in API. Now we are considering strict XML. Here is the sample configuration using strict format. The package org.apache.login.log4j.co.config.xml in module org.apache.login.log4j.co, the classes and interface supporting for XML in the API. In addition to the concise XML format before, log4j allows configuration to be specified in a more normal XML manner that can be validated using an XML schema. This is accomplished by replacing the friendly element names with the object types as shown here. For example, instead of console appender being configured using element node element name console, it is instead configured as appender element with the type attribute containing console. Here is a sample configuration using a strict format. Here you can see the strict true. Sorry. Sorry, here the small mistakes have occurred. Here the root level, and the now it's calling for here, and this is the filter. Now we are considering configuration with JSON. In this example here, the threshold filter console and pattern layout are all plugins, while the console plugin will be assigned a value of std out. For its name attribute, and the threshold filter will be assigned to a level of debug. The package org.apache.logging.log4j.core.config.json in module org.apache.login.log4j.core in API classes and interfaces supporting configuration of log4j2 with JSON. In addition to XML, log4j can be configured using JSON. The JSON format is very similar to console to the concise XML format. Each key represents a name of a plugin and the key or value pair associated with its its attribute. Where the key contains more than one simple value of it itself will be an subordinate plugin. In this example, the threshold filter console and the pattern layout are all plugins, while the console plugin will be assigned the value std out for its name attribute, and the threshold filter will be assigned a level of debug. Note that the routing appender the root element has been declared as an array. This is valid because each array element will be a root component. This won't work for elements such as appenders and filters, where each element has a different name in the concise format. Appenders and filters can be defined as an array element if each append or filter declares an attribute named type here the type that contains the type of the appender. For this example, we'll state this as well as how to declare multiple logos as an array. Oh, sorry, it's here the out is there. Additional runtime dependencies are required for using JSON configuration files. Now we are considering configuration with YAML, for example. Package in API package apache.login.log4j.co.config.yaml in package in module apache.login.log4j.co classes and interfaces supporting configuration of log4j2 with YAML. Now we are considering configuration with properties. Properties configuration files support the advertiser, monitor, monitor interval, name, packages, shutdown hook, shutdown timeout, status verbose, and dest attributes. The package apache.login.log4j.co.config.properties in module apache.login.log4j.co configuring in API configuration using properties file. As of version 2.4, the log4j now supports configuration via the properties files. Note that the property syntax is not the same as the syntax used in log4j 1. Like the XML and JSON configuration, properties configurations define the configuration in terms of plugins and attributes to the plugins. Prior to version 2.6, the properties configuration requires that you list the identifiers of the appenders, filters, and loggers in a comma separated list in properties with those names. Each of these components will then be expected to be defined in a set of properties that will begin with the component.identifier. The identifier does not have to match the name of the component being defined, but must uniquely identify the attributes and subcomponents that are part of the component. Uh, if the list identifies is not present, the identifier must not contain a dot. Each individual component must have a type attribute specified that identifies the component's plugin type. As of version 2.6, this list of identifiers no longer required as the names are inferred upon the first usage. However, if you wish to use the more complex identifiers, you must still use the list. If the list is present, it will be used. Unlike the base component, when creating subcomponent, you cannot specify an element containing a list of identifiers. Instead, you must define a wrapper element with its type as shown in the policies definition in the rolling append. You can define each of the subcomponent below here with that wrap element as the time-based triggering policy. And the size-based triggering policy. As of version 2.17.2, the root logger and logger.key root logger and and the logger.key properties can be specified to set the level and 0 or more appenders refs to create that for that logger. Level and appenders refs are separated by comma. Comma characters with optional white space surrounding the comma. This example demonstrates how to shorthand is explained when reading properties configs. The properties configuration file support advertiser. Monitor interval, name, packages, shutdown hook, shutdown timeout, status, verbose, and rest attributes. Other appender properties. Another appender properties. Is equivalent to Now we are considering scripts. That interval will be used to check the changes in the file. The interface script in API in package log4j.co.script in module log.apache.login.log4j.co. The interface script the represent ints. Log4j provides support for JSR to 223 scripting languages to be used in some of its components. Any language that provides support for JSR to 223 scripting engine may be used. A list of languages and bindings for them can be found on the scripting engine website. However, some of the languages listed here, such as JavaScript, Groovy, and Bean Shell, directly support JSR 223 scripting framework and only require that JAS for that language be installed. As of Log4j 2.17.2, languages to be supported must be specified as a comma separated list in the Log4j 2 script.enable language script system property. Components that support using scripts do so by allowing script file and script ref. To be configured on them. The script element contains the name for the script, the language for the script, and the script text. The script file element contains the name of the script, its location, its language, and its jar set, whether the file should be watched for changes. The script ref element script ref element contains the name of the script that is defined in the scripts. Configuration element. The name of the script is used to store the script along with its script engine, so it can quickly be located each time the script need to be run. While the name is not required, providing it will be help in the debugging problems when the script is running. The language must be provided on the script element and must specify one of the language name that appeared in the configuration status log. If the language is not specified on the script file element, the language will be determined by the file extension of the script path. If the file monitoring is requested, it will only be enabled if non-zero monitor interval is specified on the configuration element. That interval will be used to check for the changes in the file. If the status attribute is on the configuration file, element is set to debug. The list of the script engines currently is installed and the attributes will be listed. Although some engines may say they are not thread safe. Log4j makes steps to ensure that the script will run on a thread safe manner if the engine advertises that it is not thread safe. When the scripts are executed, they will be provided with the set of variables that should allow them to accomplish whenever task they are expecting to perform. The components that support the scripting except Components that support scripting expect a return value to be passed back to the calling Java code. This is not a problem for several of the scripting languages, but this JavaScript does not allow the return statement unless it's within a function. However, the JavaScript will return the value of the last statement executed in the script. As a consequence, the code such as shown here will result or decide behavior. Is here. Now we are considering include the XML. Here the log4j to .xml. The configuration files can be included either other files with x include. Here's an example of log4j 2.xml file that includes two other files. Here the log4j 2xml, and here the log4j dash x include dash appenders.xml, and here the log4j dash x include dash logos.xml. Now we are considering composite configuration. The default merge or strategy will merge the files using the following rules here. The log4j allows multiple configuration files to be used by specifying them as a list of comma separated file paths on log4j.configuration file, or when using URLs by adding secondary configuration locations as the query parameter name override. The merge logic can be controlled by specifying a class that implements the merge strategy interface on the log4j merge strategy property. The default merge strategy will merge the file using following rules. 1. The global configuration attributes are aggregated with those in later configuration, replacing those in previous configurations, and the exception that the highest status level and lowest mounted interval greater than 0 will be used. 2. Properties from all configurations are aggregated. Duplicate properties replace those in previous configurations. Filters are aggregated under a composite filter if more than one filter is defined. Since filters are not named, duplicates may be present. Scripts and script file references are aggregated. Duplicate definitions replace those in previous configurations. 5. Appenders are aggregated. Appenders with same name are replaced by those in later configuration, including all of the appenders subcomponents. 6. Logos are all aggregated. Logo attributes are individually arranged, with duplicates being replaced by those in later configurations. Appender references on logos are aggregated, with duplicates being replaced by those in the later configurations. Filters on the logos are aggregated under composite filters if more than one filter is defined. Since filters are not named, duplicates may be present. Filters under appender references included or discarded depending on whether they are present. The apparent appender reference is kept or discarded. Now we are considering status messages. Troubleshooting tip for the impact the following configuration has the status attribute set to debug. The package org.apache.logging.log4j.co.config.status in module log.apache.logging.log4j.co in the API. The configuration classes for status logos. Status messages from log4j 2.9 onward, log4j2 will print all internal logging to the console if the system property log4j2.debug is either defined empty or its value equal to true, ignoring case. Prior to log4j 2.9, there are two places where internal logging can be controlled. Before the configuration is found, the status logger level can be controlled with the system property log4j simple log.status logger dot level. After configuration is found, the status logger level can be controlled in the configuration file with the status attribute. For example, status configuration status equal debug, or here trace. Just as it is desirable to just as it is desirable to able to diagnose problems in application, it's frequently necessary to be able to diagnose problem with the logging configuration knowing the configured components. Since logging has not been configured, the normal logging cannot be used during initialization. In addition, the normal logging within appenders could create infinite recursion, with Log4j will detect and cause the recursive event to be ignored. To accommodate this need, Log4j 2 API includes status logger. The components declare an instance of status logger similar to here. Since status logger implements Log4j 2 API's logger interface, it's the normal logger methods may be used. When configuring Log4j, it is sometimes necessary to view the generated status events. This can be accomplished by adding status attribute to the configuration element or to the default value to be provided by the selecting Log4j default status level system property. Valid values for status attributes are trace, debug, info1, error, and vital. The following configuration has status attribute set to debug. During startup, this configuration produces like here. If the status attribute is set to error, only error message will be printed, will be written down to the console. This makes troubleshooting configuration errors possible. As an example, if the configuration above is changed to have the status set to error and logger declaration is here, this like this, and this and the following error message will be produced here. Application may wish to direct the status output to some other destination. This can be accomplished by setting the dest attribute to either error ERR to send the output to standard error, or to file location or URL. This can also be done to ensuring the configuration status is to set off. And then configuring the application programmatically such as here. Now we are considering testing in Maven. For example, here Maven can run unit and functional test during the build cycle. By default, any files placed in src /test /test resources are automatically copied to the target /test classes and are included in the class path during execution of any test. As such, the placing a log4j2-test.xml into this directory will cause it to be used instead of a log4j2xml or log4j2.json might be present. Thus, a different log configuration can be used during test than what is used in production. Second approach, which is extensively used by log4j2, is to set the log4j.configuration file property in a method annotated with before class in the JUnit test class. This will allow an arbitrary named file to be used during the test. Third, also used extensively by log4j2, is to use the logger context rule. JUnit test rule which provide additional convenience method for testing. This requires adding the log4j-core log4 and test-jar dependency to your test scope dependencies, for example here. And etc. Now we are considering programmatic configuration. Log4j2 provides a few ways for applications to create their own programmatic configuration. Specify a custom configuration factory to start log4j with programmatic configuration. Use the configurator to replace the configuration after log4j is started. Initialize log4j with a combination of a configuration file and programmatic configuration. Modify the current configuration after initialization. Now we are considering the configuration builder API. Starting with release 2.4, the log4j provide a configuration builder and a set of component builders that allow a configuration to be created fairly easily. Interface configuration builder type parameter t extend configuration in package org.apache.login.log4j.core.config.builder.api in module log.apache.config login.log4j.core. Interface for building logging configurations. The actual configuration objects like logger config or appender can be unwieldy. They require a lot of knowledge about log4j internals, which make them difficult to work with if all you want is to create a configuration. The configuration builder API in the org.apache.login.log4j.core.config.builder.api package allows users to create configurations in code by constructing component definitions. There is no need to work directly with the actual configuration objects. Component definitions are added to the configuration builder, and once all the definitions have been collected, all actual configuration objects like loggers and appended are constructed. Configuration builder has convenient methods for base components that can be configured, such as loggers, appenders, filters, filter properties, etc. However, log4j2's plugin mechanism means that users can create any number of custom components. As a trade-off, the configuration builder API provides only a limited number of strongly typed convenience methods like new logger, new layout, etc. The generic builder.newComponent method can be used if no convenience method exists for the component you want to configure. For example, the builder does not know what subcomponent can be configured on a specific component, such as rolling file appenders versus the routing appender. To specify a triggering policy on a rolling file appender, you would use builder.newComponent method. Now we are considering understanding configuration factory. Here's how Log4j finds the available configuration factories. The class configuration factory in package org.apache.login.log4j.co.config in module log.apache.login.log4j.co. Factory class for past configuration objects from a configuration file. Configuration factory allows the configuration implementation to be dynamically chosen if one of three ways. One system property name log4j configuration factory can be set with the name of the configuration factory to be used. Two, an injector binding for configuration factory may be registered. 3, the configuration factory implementation can be added to the class path and configured as a plugin in the configuration factory category. The order annotation should be used to configure the factory to be the first one inspected. See the XML configuration factory for an example. During initialization, Log4j 2 will search for available configuration factories and then select one to use. The selected configuration factory creates the configuration that Log4j will use. Here is how Log4j find available configuration factories. A system property named log4j2.configuration factory can be set with the name of the configuration factory to be used. Configuration factory set configuration factory can be called with the instance of the configuration factory to be used. This must be called before any other calls to Log4j. 3, configuration factory implementation can be added to the class path and configured as a plugin in the configuration factory category. The @order annotation can be used to specify the relative priority when the multiple applicable configuration factories are found. Configuration factories have the concept of support types, which basically maps to the file extension of the configuration file that the configuration factory can handle. If a configuration factory, if a configuration file location is specified, configuration factories whose supported types does not include asterisk or the matching file extension will not be used. Now we are considering initialize Log4j using configuration builder with the custom configuration factory. In the example here, because it specified support of asterisk, it will override any configuration files provided. The class configuration factory in package org.apache.login.log4j.co.config in module log.apache.login.log4j.co. Factory class for past configuration object from a configuration file. Configuration factory allow the configuration implemented to be dynamically chosen in 3 ways. A system property name log4j.configuration factory can be set with the name of the configuration factory to be used. Injector binding for configuration factory may be used. A configuration factory implementation can be added to the class path and configured as a plugin in the configuration factory category. The order annotation should be used to configure the factory to be the first one inspected. One way to programmatically configure Log4j 2 is to create a custom configuration factory that uses configuration builder to create a configuration. This example overrides get configuration method to return configuration created by the configuration builder. This will cause the configuration to automatically be hooked into Log4j when the logger context is created. In the example here, because it is specified supported file type of file asterisk, it will override any configuration files provided. As of version 2.7, the configuration factory.get configuration methods take additional logger context parameter. Now we are considering reconfigure Log4j using configuration builder with the configurator. However, should any logging be attempted before the configurator initialize is called, then the default configuration will be used for these log events. The class configurator in package org.apache.login.log4j.co.config in module org.apache.login.log4j.co.co initializes and configure the logging system. This class provides several ways to construct a logger context using the location of a configuration file, a context name, and a various optional parameter. An alternative to custom configuration factory is to configure with the configurator. Once configuration object has been constructed, it can be passed to the one of the configurator to initialize. One of the configuration.initialize method to set up the log4j configuration. Using configurator in this manner allows the application control over the log4j is initialized, over when log4j is initialized. However, should any logging be attempted before log4 configurator.initialize method is called, then the default configuration will be used for these log events. This example shows how to create configuration that includes rolling file append. Create console append. Create a rolling file append. Create a new logger. Now we are considering initialize log4j by combining configuration file with the programmatic configuration. Initialize log4j by combining configuration file with the programmatic configuration. The example here shows how to extend XML configuration to manually and appender and the logo and the logo config to the configuration. The module, the class XML configuration in org.apache.login.log4j.config.xml in module org.apache.login.log4j.co creates a node hierarchy from an XML file. Sometimes you want to configure Sometimes you want to configure a configuration file but do some additional programmatic configuration. A possible use case might be that you want to allow for a flexible configuration using XML, but at the same time make sure there are a few configuration elements that are always present and that can't be removed. The easiest way to achieve this is to extend one of the standard configuration classes, XML configuration, JSON configuration, and then create a new configuration factory for the extended class. After the standard configuration completes, the custom configuration can be added to it. Example here shows how to extend XML configuration to manually add an append and log a config to the configuration. Valid file extensions for XML files. Return a configuration params source the input source. Return the configuration. Now we are considering programmatically modifying the current configuration after initialization. Applications sometimes have the need to customize logging separate from the actual configuration. Here the interface configuration, and here you can see the method add append void add append in interface configuration in package org.apache.login.log4j.co.config and in module org.apache.login for log4j.co and here you can see add logger void add logger string name logger config in interface configuration in package org.apache.login.log4j.co.config in module org.apache.login.log4j.co. Applications sometimes have the need to customize logging separate from the actual configuration. Log4j allows thus this although it suffers from new limitations, from a few limitations. Log4j1 the configuration file is changed, the configuration will be loaded and the manual changes will be lost. To the modification to the running configuration required that all the methods being called add append add logger be synchronized. As such, the recommended approach for customizing configuration is to extend one of the standard configuration classes, override the setup method to first do the super.setup and super.setup method, and then add the custom appenders, filters and logger config to the configuration before it is registered for use. This example adds an appender and a new logger config using using that appender to the current configuration. Now we are considering configuration compatibility in Log4j2 compatibility with Log4j1. As support for Log4j1 is an experimental feature, one of the following steps must be taken to enable it. Log4j2 provides experimental support for Log4j1 configuration files. Configuration of the appenders, layouts and filters that were provided in the Log4j1 distribution will be redirected to their Log4j2 counterparts as an exception of the implemented rewrite policies. This means that although while the behavior of these components will be similar, they may not be exactly the same. For example, XML generated by the XML layout may not be exactly match the XML generated by the Log4j1 XML layout. In addition, Log4j2 supports custom Log4j1 appenders, filters, layouts with some constraints. Since the original Log4j1 component may not be present in Log4j2, custom components that extend them will fail. As support for Log4j1 is an experimental feature, one of the following steps must be taken to enable it. Set the system property Log4j1.compatibility to a value of true. Log4j2 will then add Log4j.properties, Log4j-test.properties, Log4j.xml and Log4j-test.xml to the configuration files it searches for the class path. Set the Log4j1 system property Log4j.configuration to the location of the Log4j1 configuration file. The files must have file extension of either .properties or .xml. Now we are considering configuring Log4j2 in migrating from Log4j 1.x. For example, using lookup for the system property named Catalina.base in Log4j 1.x, the syntax would be $Catalina.base in Log4j2 the syntax would be this one, sys : Catalina base. Although the Log4j2 configuration syntax is different than the Log4j1.x, most if not all the same functionality is available. Note that the system property interpolation via the $foo open curly brace foo post floor base syntax has been extended to allow property lookups from many different sources. For example, using lookup for the system property named Catalina.base in the Log4j1.x, the syntax would be this, and Log4j2 the syntax would be this one. Log4j1.x has an XML layout which is different from the XML layout in Log4j2. The Log4j1-1.2-API module contain Log4j1 XML layout which produce output in the format as in the Log4j1.x. The Log4j1.x simple layout can be emulated with the pattern layout. Log4j 1.x TTCC layout can be emulated with the pattern layout. Both pattern layout and enhanced pattern layout in Log4j 1.x can be replaced with pattern layout in Log4j 2. The Log4j-1.2-API module contains two pattern conversions which can be used to emulate pattern layout. Now we are considering configuration in web applications. Log4j allows configuration file to be specified in the web.xml using Log4j configuration context parameter. Log4j will search for configuration files by if a location is provided, it will be searched for as a servlet context source. For example, if Log4j configuration contains logging.xml, then Log4j will look for a file that name in the root directory of the web application. If no location is defined in our Log4j, it will search for a file that starts with Log4j2 in the web-inf directory. If more than one file is found, if a file start with Log4j-name is present, where the name is the name of the web application, then it will be used. Otherwise, the first file will be used. The normal search sequence using class path and file URLs will be used to locate configuration file. Using web application information during the configuration, you may want to use the information about web application during configuration. For example, you could embed the web application's context path in the name of a rolling file append. Now we are considering configuration in garbage-free steady-state logging. To avoid causing memory leak, Log4j will not use the thread locals when it detects that it is used in the web application when the Java x.servlet.servlet class is in the class path, or when the system property Log4j2 is isWeb is set to true. Is a web app is set to true. The public static void public static boolean is web app in class constants in package org.apache.login.log4j.util in module org.apache.login for login.log4j. True if we think we are running in a web container based on the boolean value of the system property log4j2 is log4j2.is.webapp, or if the system property is not set, whether the Java x.servlet.servlet class is present in the class path. Garbage-free logging in Log4j 2.6 is particularly implemented by reusing objects in thread local field and partially by reusing buffers when converting text to bytes. Thread local fields holding -JDK classes can cause memory leaks in the web applications when the application server thread pool continues to reference this field after web application is undeployed. To avoid causing memory leaks, Log4j will not use these thread locals when it detects that it is used in the web application when the Java x.servlet servlet class is in the class path, though when the system property log4j true.isWeb app is set to true, some garbage reducing garbage reducing functionality does not rely on the thread locals and is enabled by default for all applications. In Log4j 2.6, converting log events to text and text to byte can be done directly, encoding text into a reused byte buffer without creating intermediary strings, char arrays, and byte arrays. So while logging is not completely garbage free for web application set, pressure on garbage collectors can still be significantly reduced. As of version 2.6, the Log4j configuration containing a properties section will result a temporary object being created during the steady state logging. As of version 2.18.0, the default async logger wait strategy used by Log4j timeout is garbage free. Some of the wait strategies include in LMAX disruptor 3.4.4, especially timeout blocking wait strategy and blocking wait strategy block are not garbage free since they cause java.util.concurrent.logs.abstract queued synchronization $not object to be created. The default wait strategy used by Log4j uses a synchronized block instead of reentrant lock to avoid this problem. The yield and sleep wait strategies are garbage free. Now we are considering remotely editing the Log4j configuration in client UI in JMX. The screenshot below shows the configuration edit panel in JConsole. The client UI also contains a simple editor that can be used to remotely change the Log4j configuration. The screenshot here shows the configuration edit panel in JConsole. Configuration edit panel provides two ways to modify the Log4j configuration: specifying a different configuration location URI or modifying the configuration XML directly in the editor panel. If you specify a different configuration location URI, click the reconfigure from the location button. The specified resource must exist and be readable by the application, or an error will occur and the configuration will not change. If an error occurred while processing the content of the specified resource, Log4j will keep its original configuration, but the editor panel will show the content of the file you specified. The text area showing the content of the configuration file is editable, and you can directly modify the configuration in this editor panel. Clicking the reconfigure with XML below button will send the configuration text to the remote application, where it will be used to reconfigure Log4j on the fly. This will not overwrite any configuration file. Reconfiguring with the text from the editor happens in memory only, and text is not permanently stored anywhere. Now we are considering extending Log4j 3 configuration factory. Configuration will be passed to the node tree and instantiate the configuration object from that. The class configuration factory in package org.apache.login.log4j.co.config in module log.apache.login.log4j.co. Factory class for passed configuration object from the configuration file. Configuration factory allows the configuration implementation to be dynamically chosen in one of three ways. A system property named log4j.configuration factory can be set with the name of the configuration factory to be used. 2. The injector bindy for configuration factory may be registered. 3. The configuration factory implementation can be added to the class path and configured as a plugin in the configuration factory. The order annotation should be used to the factory to be the first one inspected. Modifying the way in which the logging can be configured is usually one of the areas of the most interest. The primary method for doing is by implementing or extending configuration factory. Log4j provides two ways of adding new configuration factories. First, by defining the system property name log4j.configuration to the name of the class that should be searched first for a configuration. Second method is defining configuration factory as a plugin. All the configuration factories are then passed in order. Each factory is called on its get supported types method to determine file extension it supports. If a configuration file is located with one of the specified file extensions, then the control is passed to that configuration factory to load the configuration and create the configuration object. Most configuration extend the abstract configuration class. This class expects that the subclass will process the configuration file and create hierarchy of nodes object. Each node is fairly simple, and in that it consists the name of the node and the name value pair associated with the node, the plugin type of the node, and the list of all of its child nodes. Configuration will then pass to the node tree and instantiate the configuration object from that. Valid extension for XML files. Return configuration, param logger context, the logger context, param source, the input source, return configuration. Returns the file suffixes for XML files and return the array of file extensions. Now we are considering defining custom log levels in custom log levels. This example shows the configuration that defines some custom log levels and uses custom log level to filter log events sent to the console. Class custom levels in API, in package org.apache.login.log4j.core.config, in module log.apache.login.log4j.core, container for custom level config objects. The custom log levels can also be defined in configuration. This is convenient for using a custom level in a logger filter or an appender filter. Similar to defining log levels in code, the custom level must be defined first before it can be used. If a logger or appender is configured with undefined level, that logger or appender will be invalid and will not pass any log events. Custom log level configuration element creates a custom level. Internally it calls the same level.forName method method. The parameter name its type is string. The name of the custom level. Note that the level names are case sensitive. Convention is to use all uppercase names. The interval type integer determines where the custom level exists in relation to the standard level build up to the log4j 2. This example shows a configuration that defines some custom levels and uses a custom log level to filter log events sent to the console. Define custom levels before using them for filtering below. Only events at diag level or more specific are sent to the console. Now we are considering configuration in usage in Apache Log4j Scala API. Log4j Scala API uses Log4j configuration by default. This supports XML, property files, and Java-based builders, as well as JSON and YAML with additional dependencies. Example, we can consider class configuration exception. This exception is thrown when an error occurs reading from passing, using or initializing the Log4j2 configuration. It is also thrown if an appender cannot be created based on the configuration provided. This in the package org.apache.logging.log4j.core.config. As an error example, we can consider this occurred in the environment with JBoss 4.0.2 with Power Analyzer. Error passing error on line 273 and column 101. Error of the content of the element type log4j configuration must match render asterisk, append asterisk, category logger asterisk, root, category factory, and etc.